Hi guys, I'm Miss Sana Kang, and we're gonna learn geometry now. This is lesson 1 of geometry, segment length and midpoints. The essential question is, how do you draw a segment and measure its length? So before we do that, we need to study vocabs. There are a lot of vocab in geometry. So in geometry, some of the names of figures and other terms will already be familiar from everyday life. For example, a ray, like a beam of light from a spotlight, is both a familiar word and a geometric figure with a mathematical definition. The most basic figures in geometry are undefined terms, which cannot be defined using other figures. The terms point, line, and plane are undefined terms. Although they do not have formal definitions, they can be described as shown in the table. So these are the undefined terms. A point is a specific location. It has no dimension and is represented by a dot. A line is a connected straight path. It has no thickness and it continues forever in both directions. A plane is a flat surface. It has no thickness and it extends forever in all directions. Both directions, all directions, no dimension. And these are the qualities of point, line, and plane. Okay. In geometry, the word between is another undefined term, but its meaning is understood from its use in everyday language. Between. You can use undefined terms as building blocks to write definitions for defined terms as shown in the table. So these are defined terms. A line segment. So a line is undefined, but a line segment is defined. It is a portion of a line consisting of 2 points called endpoints and all points between them. Okay? If you look at the figure, there are no arrows on both sides. Whenever you look at these are line segments. A ray is a portion of a line that starts at a point, the end point, and continues forever in one direction. So if you have a line that is cut in both ends or just one end, they're both defined terms. Okay? Only when you have a line that's like infinitely stretching, this is undefined. Alright, so practice. Example A, draw 2 points J and K, then draw a line through them. So you're going to do it by yourself if you can do it, by pausing the video and playing it back after you're done. But if you don't know it, it's okay. You can look at my example. Draw 2 points J and K. You can just draw anywhere, J and K, and then you're going to draw a line through them, and it's a line that's infinitely stretching. Okay, arrows at both ends. B, draw 2 points J and K again. This time, draw the line segment with endpoints J and K. Can you do it? Endpoints J and K. So these two are endpoints now, which makes this a line segment, J and K. So if you were to write them, you're going to use arrows like this, J and K. If you were to write them on the sentence, these are the representations. Okay, C. Draw a point K again and draw a ray from endpoint K. Plot a point J along the ray. Draw a point K. Draw a ray from endpoint K. Plot a point J along the way, so anywhere on the ray. Okay, so this is K and J, but K is the endpoint, so you have to make sure that the arrow is above J when you represent this. Okay, D. Draw 3 points J, K, and M so that they are not all on the same line. Okay, J, K, and M, 3 random dots. Then draw the plane that contains the 3 points. Okay, you might also put a script letter such as B on your plane. So a plane, which is usually represented as a square, like a rectangle plane. You can say plane B. And E, give a name for each of the figures you draw, then use a circle to choose whether the type of figure is an undefined term or a defined term. Okay, point. What do we have? We got points J, K, what else? And M, and these are undefined terms. What about lines? We have one line, that's undefined term. Line is going to be undefined, and that is going to be JK. Line segment, line JK, okay? Line segment is going to be KJ. Wait, this is Ray. JK. Line segment is JK. Okay, and ray is gonna be KJ. Segment, defined term, and ray, defined term. Plane B. And that is an undefined term. Okay, now you got it? Alright, explain number 1. Constructing a copy of a line segment. The distance along a line is undefined until a unit distance, such as 1 inch or 1 centimeter, is chosen. Okay? So a distance is a distance. It's undefined until you have like a measure, like a centimeter, millimeter, kilometer, whatever the distance unit measure you have. Feet, inches, yeah, stuff like that. You can use a ruler to find the distance between 2 points on a line. The distance is the absolute value of the difference of the numbers on the ruler that correspond to the 2 points. So distance, again, is going to be all positive numbers. All positive numbers. This distance is the length of the segment determined by the points. In the figure, the length of RS, line segment, note that, because there are no arrows on both sides, written RS or SR is the distance between R and S. Okay, that makes sense. So R, which is exactly at 1 centimeter, and S, which seems like it's at 4 centimeter, is gonna be your point. How do you define the distance between the 2 points? Well, if R is 1 and S is 4, then how many centimeters do you have in between? We got 1, 2, and 3 centimeters, right? That's 4 minus 1, which is 3. So 3 centimeters. Or 1 minus 4, but that has to be absolute value, so it's still going to be positive 3. Points that lie in the same plane are coplanar. Lines that lie in the same plane but do not intersect are parallel. Okay? Points that lie on the same line are collinear. The segment addition postulate is a statement about collinear points. A postulate is a statement that is accepted as true without proof. Like undefined terms, postulates are building blocks of geometry. We're gonna look at a lot of postulates in geometry. So postulates number 1. Segment addition postulate. Let A, B, and C be collinear points. If B is between A and C, then AB plus BC equals AC. So they're all collinear, which means they're all in the same line. If B is between AC, right? If they're in the same line, then there is no way that B is going to be outside the line segment AC if B is between A and C. Does that make sense? If it's between AC, B is gonna be like anywhere between AC, like on this line, on this one line. So it could be any point here. Okay, so AB plus BC is gonna be equal to the line segment AC. That's the postulate number 1. A construction is a geometric drawing that produces an accurate representation without using numbers or measures. One type of construction uses only a compass and straight edge. You can construct a line segment whose length is equal to that of a given segment using these tools along with the segment addition postulate. So let's look at example 1. Use a compass and a straight edge to construct a segment whose length is AB plus CD. Okay, so if you have a line segment AB and another line segment CD, you want to draw like one line that's the total distance for the two line segments. So step 1, you're going to use the straight edge to draw a long line segment. Okay, so I'm sorry, this is not straight, but it's a long line segment. Imagine this is straight. Label an endpoint X. An endpoint X. Okay, so I don't need a arrow. This is X. Okay. Whoops. I drew it the opposite way. But to copy segment AB, you're gonna open the compass to the distance AB. So if you have a compass, you have that angle, right? So you're gonna match it with the points A and B with your compass, and then you're gonna hold it and put it on your line, your X line, okay? And then you're gonna put a point there. So let's say this is A and B, right? I'm drawing backwards. To copy segment C and D, you're going to do the same thing. Put the compass on C and D, and then you're gonna take the compass out and place it on your line that you're drawing from, but then you're starting from B. Okay, and then so if you draw it, maybe you have a point here. Okay, if you like rotate it, you're gonna have these drawings. Okay, and so you can say this is like C to D, and so then you have AB plus C and D together, and you can say, you can name this AD or a new line. All right. B. Now we got another new set of lines. Do the same thing. I'm gonna leave this up to you. Okay, explain number 2. Using the distance formula on the coordinate plane, the Pythagorean theorem states that a squared plus b squared equals c squared, where a and b are the lengths of the legs of a right triangle, and c is the length of the hypotenuse. This is hypotenuse. You can use the distance formula to apply the Pythagorean theorem to find the distance between points on the coordinate plane. Okay, the distance formula states that the distance between 2 points, x1, y1, y sub 1, and x sub 2, y sub 2 on the coordinate plane is square root, parentheses, x sub 2 minus x sub 1, all of that square, plus y sub 2 minus y sub 1, and that is also squared. So using the distance Pythagorean theorem, you can write a distance formula like that. So if this were to be your hypotenuse, right, and that to be a and b, you know that a squared plus b squared is equal to c squared, right? If you want to figure out c, what do? Then, you know, this length is the x length. So your point here, x sub 2, minus, you have to subtract this x sub 1, right, point, whatever your points are. Okay, and this part, A, the length of A is your y's. So y sub 2 minus y sub 1 is gonna be your y length. Okay, so then you're gonna have a squared plus b squared, but then if you want to know just c is equal to what, then you're gonna do square root, right? The opposite of square is square root. So that's how we got the distance formula from the Pythagorean theorem. So example 2, we're going to determine whether the given segments have the same length. Justify your answer. Okay, so we're going to compare the segments and see if they have the same length. They kind of look like they have the same length, but we're going to use the distance formula to be exact. Okay, let's look at the line segment AB and CD. We're going to write the coordinates of the endpoint. So first, we need to figure out what the points are, right? You can count them. Count the x first, right? 1, 2, 3, 4, minus 4, comma, 1, 2, 3, 4. 4 is your A. B is 1, comma, 1, 2, 2, right? C is 2, comma, 3. D is 4, comma, negative 2. Okay, so we're going to find the length of AB. AB, you can pick whatever points as your first point or the second point. It doesn't matter. You're going to get the same answer. But just make sure that these 2 points, these 2 numbers align together. You have to, if you chose A to be the first point, that you need to be consistent, okay? So 1 looks like we chose B as our first point. So B, x sub 1 for B is going to be, x sub 2 for B is going to be 1 minus negative 4. That's going to be 5 squared. And 2 minus 4 is going to be negative 2 squared, which is 4. So you have, after you simplify it, you have square root 29. This is your distance. You don't have to calculate it. Just leave it like that. Find the length of CD. Same thing. You're gonna use the points C and D. 4 minus 2 squared is 4. Negative 2 minus 3 squared is gonna be 25. If you add them, square root it, it's gonna be square root 29. Wow, what do you notice? They're the same, right? So AB and CD have the same length. Length of AB is equal to length of CD. Okay. EF and GH. You're going to do the same thing. E is negative 3, 2. F is negative 2, negative 3. G is negative 2, negative 4. H is 2, 0. You're going to find the length of EF. You're going to use these 2 points, EF. We're going to use F first. So negative 3 minus, negative, this is X, right? Negative 2 minus 3 square plus negative 3 minus 2 square. Okay, negative 2 minus 3 is going to be what? 1 square. And then negative 3 minus 2 is negative 5 square. That's going to be 1 plus 25, so 26 square. Okay, now G and H. Your H is 2, 0. So 2 minus 2 is 2 plus 2. 4 square is 16, sorry. Plus 0 minus 4 is 4. Square is also 16. So square root 16 plus 16 is 32. Are the length the same? Length of EF and GH, are they the same? No, because they're different. So what can you conclude? EF, line segment EF, does not equal to the line segment of GH. Therefore, EF, line segment EF, and line segment GH do not have the same length. Okay. You can do that for all the other lines too.